Welcome to EDU World Space.
In this problem, we're given a mobile with light rods and light strings and beach souvenirs hanging from it. And so I've just represented those as balls here. And here's our rods and our strings, and we're assuming these are massless compared to, at least compared relative to these. And we're given all of these lengths here. Okay, so the length of each bar on each side of where the string is that's holding it. And so we're given each of these lengths, so LA, B, C, D, E, and F. Okay? And then we're also told that this souvenir here has a mass of 12 kilograms. So then we're asked for what the masses of all of these are, assuming that this mobile is in equilibrium. So we can figure out what this is because we know if we take moments about this point, we're going to wind up with M4 LA must equal M1 LB. Okay, so there's a G in here that I've canceled out because of the weights, but it's common in all of these factors and all of these terms. So that simply tells us that we can solve for, we know everything in here except for M1, and we can solve for it, and we get that M1 must be 9 kilograms. And then we can move on up to this bar, and taking moments about this point, why we take moments up at this point is because there's a reaction force there that we don't want to mess with. We don't really care what it is, although it's actually pretty easy to solve for because it's just the sum of these two weights. But we can take moments about here, and then that drops out of the equation. So in this case, we need to take we're going to take moments about this point so that the force here doesn't show up, and that tells us that M2L C times G, and again there's a G that I've dropped out, must be this distance times the total weight, the force and the weight acting, or the tension in this string, which is the weight of these two blocks. So that says that M2 is LD over LC times M1 plus M4, and if we plug in those numbers, we get that M2 must be 52.5 kilograms. And finally, we can look at this bar here and take moments about this point. And when we do that, we get, again, there's a G in here that I've canceled out. LF times M3 must equal LE times the total weight of everything, the tension in this string, which must be the total weight of all of the things underneath of it. So that's M1, M2 plus M4. And we know everything in here now except M3, and we can solve for it, and we get that that's 49 kilograms.